Our next speaker is Matthias. He's a tech evangelist at Always Data, and he has always made security and privacy was one of his challenges for the web. He defined himself as a curious pet and a chronic optimist. Today, Matthias will talk us about zero-knowledge architecture. Welcome. How are you?
Yeah, I'm fine. Thank you. I'm really happy to be here with you. Thanks.
Me too. You know, me and Matthias met each other, I think, 2-3 years ago. We already talked about this in a previous edition of Node.js, so I'm very happy to see you back here. So and enjoy the talk and see you in a bit.
Yeah.
Thanks for being here for this new edition of Node.js Online. We're going to have a quick talk about what a zero-knowledge architecture is and how you can use it in your everyday development. We're going to have a look at what zero-knowledge architecture is and how to build a zero-knowledge backend using Node.js. First things first, why using a zero-knowledge architecture and what it is? Its purpose is to protect your users' privacy and your users' data flow. We are producing, as final users, a lot of data. And this data transits between client and server back and forth every day continuously. We couldn't take the risk that this data could be stolen or could be misused by any kind of companies that could have access to this data. So we're gonna have to find some kind of useful design patterns that help you to protect your users' privacy. Because if users can protect themselves, this is our responsibilities as developers to protect them. So we will rely on encryption, and I mean a lot of encryption. But fortunately, this encryption occurs in the client itself, or in the various clients that you will use to use your application. And your backend by itself has to be agnostic, which means you can use any kind of technology you're comfortable with to build a backend dedicated to a zero-knowledge design pattern or a zero-knowledge architecture. So to help you to build this backend, we will rely on Node.js, thanks to some advantages brought by the language and the ecosystem itself. But to have something really agnostic, we will stick on the venerable HTTP verbs. The HTTP protocol defines a lot of actions that you can use to simply put or get or post some kind of data to your server. So this is useless to try to find a new protocol or a new standard to help you to develop a new zero-knowledge architecture or zero-knowledge pattern. You just have to stick on the HTTP verbs and use them in your everyday actions. So what is a zero-knowledge architecture exactly, and how does it work? It's a design pattern that helps you to enforce your users' privacy, which means that we will try to protect any kind of exchange that occurs from the client to the client, whatever the backend is and whatever the data will be transferred between any kind of application. So we will use end-to-end encryptions, which means the data will be encrypted in the client, transmitted to the server or the backend, and then restituted to the client or transmitted to another client and deciphered on this other client. So you don't have to deal with encryption at all in your backend. It will use asymmetric keys for each ends, especially when you want to share some kind of content. If you don't want to share some content, you can rely on other kind of keys, but with sharing involved in your architecture and in your design, you will probably have to rely on asymmetric keys. So for a reminder, an asymmetric key is for each user that can access a kind of data. You will have a pair of keys, a private key and a public key. And the content encrypted using the public key could be deciphered only by the private key that is associated to the public key previously used for the encryption. So if I want to share some kind of content with another user, I will use this user public key, and this user will use its own private key to decipher the content that I transmitted to him. This is exactly the concept behind GPG, and this is something really useful. But it is something that is really consuming in terms of computing task. So we will not use asymmetric keys for the data encryption itself, but only for a symmetric key that will be used to encrypt just a small chunk of data. So each time I want to share some data or store new data on your backend, I will generate a random symmetric key. I will encrypt the data with a symmetric key, and I will encrypt the symmetric key with the public key that I will use for the transmission to another user, or to myself if I just want to recover my data later. Okay, I hope you are following me in this kind of concept. This is not really essential to understand what a backend, zero-knowledge backend is and how does it work, but you have to keep in mind that you want to encrypt the data in the client using a key, probably a symmetric key, and transmitting the data over an asymmetric wrapping using asymmetric keys, and these asymmetric keys will be used in the backend itself. All right, then. Let's go then. So what are the backend roles in this architecture, which is a little bit complex to understand and to put in place? First things, your backend will have to store and to return the encrypted data, which is kind of persistence and kind of storage directly into your data backend. So the backend by itself won't encrypt or decrypt any kind of content. It will just stores and returns the data that is passed to it. That's all. It will manages public keys and tokens that will be used to encrypt data and to secure some exchange between different kind of clients. So this is also the backend role to manage the distribution of public keys and tokens. It will deliver certificates because we will rely on certificates to host the different keys and different identities of the clients that will be used to access the encrypted data and data chunks. So it will also manage and distribute the certificates, and it will invalidate the expired payloads because you probably don't want to let access to some kind of data all the time to another clients or to another user. So you probably want to define at some point an expiration time, and this expiration is managed by the backend itself. And that's all. You don't have to do anything else on your backend side. All the rest is on the client side. So from the backend point of view, the client-server workflow is this one. First, a new client will register on the backend, getting the root certificate hosted by your backend application. This is the top certificate in the kind of pyramid of authentication and validation between different organizations and different users inside those organizations. This is exactly the same protocol that is used by TLS, which is the protocol that protects the HTTP connection in the HTTPS protection. So your backend has a root certificate, which is the top certificate, and when a new client registers, then your client will get this certificate to generate some kind of identity on the client side. Then on the client side, the client generates a new key pair, protect them using the application certificate, signing them by the application certificate, and will post the public key and some kind of hashes, like the private key hashes, to the backend server to store them on the backend server, so the backend could be able to distribute the public key to other users that want to share some content with this new user. Okay? Then your client will encrypt some kind of data using a wrapped key, like we said before, and will sign it using its private key, and then put this chunk of encrypted data on your backend, on the server, by just putting it on the server. Then the server will validate the timestamp inside the putted payload, and they will validate the signature before returning a validated payload to the client. This is a basic client backend workflow in the kind of zero-knowledge application. So, in this context, what exactly are the backend behaviors that we want to use in our zero-knowledge architecture? First mission is authentication. We want to identify users, we want to create new accounts for storage on the backend, and we want to link different shares between recipients, which means each time I want to share some content with another user, I have to maintain a link for a dedicated chunk of data from me to this other user. So this is a backend responsibility to maintain the state of those links. This is the kind of authentication the backend is responsible for. You also have a key management, as we said previously, dedicated to the backend. So the backend will generate new certificates managed by the root certificate of the backend application. It will store the different keys, and eventually, optionally, it could be useful to have a hardware secure module that is responsible for the cryptographic operation plugged in the backend server. But this is only if you want to protect your cryptography operation, the backend, like certificate generation. So this is not mandatory on your backend, but you could rely on it. So how to secure the data? We will rely on the JSON Web Token. JSON Web Tokens are some kind of JSON model that is defined in an RFC, and this definition hosts different kind of data, like a UID, which correspond to your user, some various kind of parameters, like the keys, salt, the parameters used to encrypt and decrypt your data, and your data chunk. And this JSON Web Token is used to protect your data, to sign it, and to ensure the data isn't altered, isn't tampered between a transmission when you transmit the data from the client to the backend. This is why JSON Web Token is probably the best format to use to manage the exchange between your clients and your backend. The persistence will be done in a document-oriented database, simply because it's probably simpler to have some trees of content rather than a relational database. So we want to use a document-oriented database in our backend. And we have to transmit some kind of operation. Ideally, your clients have to be notified where new sharing is available, and your backend server don't have to be centralized but distributed in a mesh. So you will probably have to rely on a queue messaging solution to ping the different backends, and to rely on ActivityPub to notify different users in kind of data transmission. Another useful kind of use of ActivityPub is that you will simply rely on it to federate your different kind of server backends. So on the backend, what is the workflow you have to put in place to have zero-knowledge backend application? First one, we want to create new users. Those users will be responsible to put some data and retrieve some data on the server that will be encrypted on the client. Then, the backend will return a user's JSON Web Token. This Web Token will contain any kind of information that your clients have to be aware of on the client part, like the certificates that will be used, the parameters to use, the cipher algorithm to use, and so on. Then the backend will handle the posted messages to register new data chunks each time the clients want to store new data chunk to the backend, you will simply handle the post request on the backend. You will also handle the patch request on the backend, because each time you want to post some content, the backend will return some validated data, and the client will update the data with this returned and then patch the data on the backend itself. And the backend will check the signature and expiration time related inside your application. Then the data will be returned or will be served to other clients, or the backend will serve error codes in terms of some errors or some invalidation in process. Okay, so this is for the theoretical part, and this is really huge, I know, but we can simply build it using a Node.js ecosystem and by creating a Node.js application. First thing, why Node.js? Because first, it's fast. Really. It's a simple and really elegant language. We can use any type of modules that are already available through NPM. So we don't have to develop a lot of logic by ourselves, but just aggregate some useful modules all by all. It will use a JSON language natively, which is a language we will rely on thanks to the JSON Web Token format. It is perfectly resilient, and we have a lot of front ends that will be compatible, because if you want to develop any kind of client's library, it will be really easy to do it with JavaScript. So you will stick to the same language to develop both your backend and your front-end applications if you want. So this is a good reason to stick to Node.js to develop the backend. But once again, it's perfectly agnostic, so be free to use another language if you want. So on the server part, first module will be used is the Restify framework, because it's a framework dedicated to build the REST interfaces, which is exactly what we want to do, because we want to use the HTTP verbs to generate some kind of contents. So we have to build the REST application, the REST API, and Restify is the perfect client to do it. We have handlers chained with pre-handlers that are some kind of decorators. It handles hypermedias, which will be really useful when we want to link shares between various kind of clients. It is versioned by design and really smart at failing, because you can easily generate error codes in kind of any errors in your application. So this is a perfect client, the perfect base, perfect framework to build our backend, zero-knowledge backend application. Simple setup. We just require Restify. We will simply create a new server. We will have some kind of recipes that were declared, like get some kind of URL, and we just listen at a dedicated port, and so on. Easy, efficient, perfect. So we have to secure our exchange. The best way to do it is to use Node.forge. That is a module dedicated to certificates implementation. It's completely compatible with the X59 protocol, that is the protocol used for certificates, like in TLS. And it's a full TLS native implementation. So that's perfect to handle our certificates logics inside our application. So we will create a new key server on our application by requiring Node.forge. We create a new store using the application root certificate that will be used to sign all the certificates in the application by itself, which means each user's certificates. Then each time I want to create a new user by posting to /users. I will create my user, and I will return the certificate containing the new certificate associated to the user and associated to the user's UID. This is the best response you can give to your application, because your client will just get the certificate in return and everything is inside it. So it's ready to use and ready to understand on the client side. Then each time I want to post new user's content by putting some new kind of data associated to your user, like the login, public key, whatever you want. You just have to put on the user's UID, and you will identify your user and store any kind of application signed by the user certificate delivered previously when the user registered, and then return just 204 code when your user is updated. And that's all. That's for securing the user's identity. Then you want to store some content. Best way to do storage is to use MongoDB or CouchDB, a document-oriented database, as we said before. We will use a simple documentary structure. This documentary will be one document per user. Each document contains the UID of the user, the username, password, hash, signature, and salt used for the password, not the password by itself, but only the hash, thanks. The encryption keys, so the public keys and the private key hash, the various house keys you will be used in case of zero knowledge proof, like the pub keys, if you want to use another asymmetric keys pair for authentication and not for encryption, the certificate hash, and a list of items that are some kind of data chunks. And for each item, a dedicated UID, a salt, some parameters, the data by itself, and the recipient ID that the data will be delivered to. So it could be another user you want to share some data with, or it could be the user by itself in case you just want to back up some data and retrieve it later. About authentication. There is two steps. First step is creating the account by posting the username and password to the platform. The platform will handle some kind of contents like username, password hash, certificate hash, and so on, and will return the JWT, the JSON Web Token, that the user will use to protect the data later. So how to do that? Each time we post to server the username and login, we want to protect our data and redirect the data to its login. And each time you want to get the user's /name, we get the JSON Web Token associated to the user. So we will use Passport to do that because we will use a local strategy based on our database. So we will find new users, find the user in the database. In case of the user isn't available, we return an error. If the password isn't good, we return an error. Otherwise, we return the password, the user by itself. And we rely on this Passport middleware to simply do the authentication inside Restify, which is pretty easy and pretty simple to put in place. A good way to use Passport is that if you use it for your application, you can rely on other strategies like an LDAP strategy or something like that, and you don't have to rely only on a local strategy to do that. Then we want to protect requests. We will use TLS, we will use cores to protect the domain request and the JSON Web Token. So TLS is built in using Node.js. So for cores, we just have to call Restify cores, and using the middleware simply by allowing some kind of origins and some kind of headers, and just rely on this cores recipes directly in our Restify endpoints. So that's perfect to use. So actions are now identified and protected and will be with JSON Web Token. So to do that, we rely on Restify JSON Web Token community module. It's another middleware. We have an authorization parser, and each time we want to get a list of items, we will first check the JSON Web Token using the server secret token. And if the user is not the owner of the items we want to list, we just return an error. Otherwise, we can return the list. So what when a user wants to post some content on your backend? First thing, the client will derive some keys from the password. Then it will post with the JSON Web Token the content on the backend itself, not the encrypted content, but the metadata of the content. It will be the source, use the recipient UID, the algorithm parameters, and an optional expiration timestamp in case you want to expire your data. Then the backend will return the updated JSON Web Token and the item UID, which is prepared to handle the data on the backend side. We will use a plugin called Body Parser. We will simply parse the request, the post request, and return the correct created new item UID to the user. Then the client will encrypt the content on its own side, creating a payload with the encrypted data, the wrapped key, the optional timestamp, and the signature. And there will be an exception if the data already exists on the backend side. So I've got a UID for an emplacement prepared for my data on the server on the backend. So I will just put my data on the backend by giving it the requested UID for the item. I will find it. I will return the conflict error in case of data conflict on this item part. Otherwise, I will get the timestamp and the signature, check the signature, check that the timestamp is still validated, and return an error in case of failure of the signature. Otherwise, save the data. About the user by itself, each time I want to get a new user reference inside it, I will rely on passport, I will rely on JWT token with UID and username, and I will use hypermedias for belonging items. So each time I want to get a user content, I want to ask for it using the passport authentication. I will return a username, the public key of my user, and a list of items that are an hypermedia list link of my different items associated to this user. Then I will embed everything, every content in a JSON Web Token signature, and it will pass it to the payload from the backend to my client. When I want to get some data chunks and I want to retrieve some kind of data from the backend, I want to have to check the signature using my public key, check the expiration timestamp, and then return the data or an exception in case of error. So I want to get my collection of items. I will request a specific items. If this item doesn't exist, I return an error. In case of this item doesn't belong to me, or I'm not authorized to access this item, I return an error. In case of the expiration of the item is expired, I return a precondition fail error because the backend won't allow to serve some kind of content that is previously expired. Otherwise, I will check the signature, check that the content didn't have been tampered on the backend itself by some malicious attack. And if the signature is still the good one, then I will return the content. Bonus part, why using the zero knowledge backend? A good thing is sharing the data with other users. So I can share my payload with another user using a zero knowledge proof, which means I will put my checkup data into a public space to my user recipient. So if I want to share some content with another user, I just put in the basket the data, the encrypted data that I want to share with him. It will return to me a JSON Web Token. I will update this JSON Web Token with my signed content using my private key and push it directly to the user. Then the user will be flagged, and the final user will be able to retrieve my new content directly inside its private space. So it's finally just a simple REST ping pong between my application, my client application, and my backend server. Each time is just, I want to create something, the server say, okay, you're gonna have something, here's a token to use. The client side say, okay, I will use the token, I encrypt the content using the token, and I return it to the backend. And the backend is just storing it. And each time you want to retrieve it, the backend will just perform some checks on the content, no alteration, no tampering, no expiration, and then allow the content to be retrieved by the user or to be get by the user you want to share the content with. This is a simple REST backend. So it's not really complex, obviously, but on the backend side. On the front end, it involves a lot of content. Mostly on the backend, it's just a REST API with some kind of crypto sugar, just here to protect some kind of exchange, but that's all. So your tools will be the JSON Web Token, the kind of the understanding of signatures, and the using of dead time tokens to handle the expiration parts. And that's all. All the rest is on the client side. And on the client side, it will require a lot of cryptography. And if you want to know more, there is a few good talks about zero-knowledge architectures, what it is, and how to use it in your client application. But for the backend side, that's all. You don't have to handle more content and more complex logics. I'm Matt. I'm a tech evangelist at Always Data, which is a cloud provider. And as a cloud provider, we're especially concerned about the security of the application our clients host on our infrastructure. And this is why we're evangelism for all these contents based on zero-knowledge content, cryptographic contents, and zero-knowledge architecture, because we prefer that our clients understand how does it work and put in place some kind of protective backends for final users, rather than using some risky backends that aren't protected correctly. If you've got any question, this is right now in our Q&A session, and it will be live just now. Otherwise, thank you very much for being here at this Node.js online edition. I hope you are now a bit more understanding of this zero-knowledge concerns, and I'm here for your question. Thank you very much.
So here we are. Thank you for the talk, Matthias. It was very, very cool. And I wrote down a couple of questions for you, but I've lost the key. So there's only a way for recovering them. So I guess a question I can ask you while I try to find again the key is there a way for the backend to access the encrypted data in a zero-knowledge architecture?
Yeah, that's a good question. Your backend can't access the data that was encrypted in the client, except if the private keys are available on the backend. But in the zero-knowledge architecture, the private keys are supposed to stay on the client side only. So there is no way for the backend to decipher any kind of data that was just put on the backend side. So no, this is why it's a pretty much secure architecture for your application. You can't access the data by itself on the backend, but only on the client side.
Okay, interesting. So luckily I was able to find again the key. So a question I was wondering while looking at your talk. So how much the backend knows and should know about a user? So let's say you want to log that something has happened. How much you know about the user? How much can you also log about it? And what you should log also?
That's a good question. You can log some kind of exchanges. You can log basic actions like login when the client or when a user get access to some content or put new content on the server. But except that, you can't really log or access any kind of user's data on the backend. That's there's two sides. The first one is that this is not much information stored on the backend, so it's pretty secure for your users because there is not much information exchanged and stored on the backend itself. But if you can access just the logs and access some kind of timestamp when a user put a content on the server, exchange some kind of content with another user, if you log all the tracks, it can give you some hints on your user's activity. So it's a good way, if you really want to protect your user's privacy, to not to log a lot of information, because all those metadata informs a lot about your user's activity.
Okay, so yes, it's I guess a question of trade-off. Try to log only what you really need to know. Okay,
yeah, exactly.
So now so what are the drawbacks of zero-knowledge architecture? What is a good use case for a zero-knowledge architecture? What is a really bad case for it?
A really good use case is when you want to build some kind of private exchange application, like a private messaging application. Signal, the Android and iOS application dedicated to instant messaging, is a perfect example of a zero-knowledge application. It's a really good use case. A bad use case, or not that good use case, is if you have to perform a lot of action analysis of your users' data because you want to improve their experiences in some way, in some action, like performing some kind of big data's algorithm on your users' data, because you can't access the data by itself. So it's a complete black box for you on your backend side. So for this kind of application, when you want to enrich and you want to build some kind of recommendations based on your users' data, this is not a really good pattern. Or you can do it, but you can do the recommendations on the client side. So so you can push some kind of recommendations algorithm to your client. And in the client side, the algorithm can be run on your users' data, and you can get some kind of recommendation for your final user. But all the computation is on the client side and on the backend, so you can't really know, or you can be aware about what the recommendations are and what your algorithm really recommend to your client.
Okay, so you can also do as a follow-up of what you just said, which I think is already a perfect answer. Can you do like an hybrid system? So let's take Twitter. All the tweets are public and handled by the backend, but all the private messaging are done in a zero-knowledge fashion. Would it be possible to do a hybrid solution like this?
Yeah, definitely, and it could probably it could be a really nice solution, because you can easily have a mix between public information and private information, and private information stays private because it is encrypted in the client side. And this is a good way to prevent any leaks of informations and private information in case of malicious attack or in case of bug in the backend software. It's a bit more complex to implement because you have to implement all the crypto logic on the client side. But yeah, this is definitely possible. Okay,
great, nice, very nice. So given today we talked also about serverless, a question that comes to mind is using serverless, is having implementing everything with serverless a good thing, given that at the very end, the zero-knowledge architecture, what it's really doing is serving chunks of data?
Yeah, we can rely on the serverless architecture because finally, as I said, the zero knowledge backend is just a REST API with some crypto stuff on it, just to control the certificates and to control the expiration time using dead time tokens. So it's totally possible to rely on serverless architectures to host and to develop a backend, zero knowledge backend. It's probably more simpler because if you have to implement something on the backend, it's probably just the crypto layer, which is really easy to develop using some existing modules. So yeah, relying on serverless architecture is a perfect use case because you can easily scale up your architecture using all the power brought by serverless architecture, because all your backend just have to store some kind of data and retrieve it to your user. So it's perfect for a meshed architecture with some decentralized servers. So yeah, serverless is a good option.
I see also it would be a good option given that especially Node crypto is usually very, very expensive and synchronous. So being able to scale very quickly is definitely a good thing to do.
Yeah, definitely. And because all the complex crypto actions are on the clients, they're not do not depend on the power of your backend. So yeah, it's easier to scale up.
Okay, nice. Well, thank you a lot for your time and for your talk. As I say, it was very, very cool. Hope to see you next time in person. And also from the backstage, they told me that the first time we met each other was the Node.js Italian Conf, which is the old name in 2018, so 2 years ago.
Yeah.
So see you next time, and thank you again.